In this lesson, we're going to focus on users' roles security against a SOAP-based web service. The examples we've seen so far have used REST-style services and, of course, clients against those services. So to begin, we need a service. This is a minimalist service, quite deliberately. We don't care so much about the operations. We just need some example. So this is the temperature conversion service. It has two operations: centigrade to floating point conversion, floating point to centigrade conversion. And you'll notice, as in the REST-style services, there's nothing in here that hints at security, and in particular, at users' roles security. All of that is done in the configuration, and the web.xml used for this service is essentially the same as the one used for the REST-style services. In fact, the security sections are exactly the same. There's no change at all. The only difference is that the SOAP-based service needs a so-called interceptor servlet that we talked about earlier. There's also no change whatsoever to the Tomcat configuration. Everything remains the same. So this service, as you can see, the source file is tempconvert.java, is deployed in the usual way. And in fact, in the working files, there is a zip file called soapurs.zip that contains all of the files that we're going to be looking at. So that's for convenience. And there's a README in there to remind you about how to compile and run the client. The WAR file is included. Now let me turn to the client code because that's our main interest. And this file is an abbreviation of the actual client. So this working file is called tempconvertclientshort.java. It won't compile because I've deleted the imports and other extraneous information, but the actual client code is included in the zip. I have the lines numbered again, but I'm going to actually start near the bottom and then move up to the top. So let me go down to line 5 and explain what that is. A binding provider in the context of SOAP-based web services is basically the transport level. So up here, what we're creating is a temp convert instance, in other words, an object that allows us to invoke the operations in the service. But now what we need to do is get down to the transport level. In this case, it's the HTTP level because we need to inject the username and the password into the HTTP request. The data type that Java uses in Java SOAP-based web services is called the binding provider. So I get the binding provider, and then down at lines 6 and 7, I use these put operations. Basically, the request context that you can see here is a map that represents the HTTP request. So I put in the username, the key, and then the actual username. In this case, once again, it's Mo. And then the password, and once again, the password is Mo, 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 with the M's capitalized. By the way, this username underscore property and password underscore property are simply strings, and in the comments I've shown you what these strings are. So in effect, down here, this first key, that string, is followed by a colon, followed by Mo, the username, and then the second key, this one, password, followed by a colon, followed by Mo's password. Now this is slightly higher level than what we saw in the REST-style clients. In those clients, we were very close to the HTTP metal. We had to combine the username and the password, as you'll recall, into a single string. We had to base 64 encode that string. In other words, we had to basically follow the HTTP 1.1 spec. In the SOAP client, we're working at a slightly higher level, so a more intuitive level, if you like. And that's appropriate because SOAP is further from the HTTP metal. Now let me move all the way back up to the top to line 1. You'll see that this code occurs in a static block. So let me explain what I'm doing, and then we'll look at the details. Suppose you're in development mode and you don't want to create even a dummy trust store. So the dummy trust store we've been using is a file called test.keystore. And we created that using the key tool. But suppose you don't want to do even that. So you want to use HTTPS, and you can see up at this line, the URL starts with HTTPS, but you don't want to do the mutual challenge part of that. Well, Java provides a number of ways to work around that. You could do one of these at the command line, but I prefer to illustrate in the code because I think it makes things clearer. So at line 1, we create a trust manager, which is basically an array, and we're going to put one thing in that array. So you can see here, new X509 trust manager. X509 is the standard format for a digital certificate. And then in the body of this constructor call, we define 3 methods: get accepted issuers, check client trusted, and check server trusted. So at lines 2, 3, and 4. And you'll notice, of course, that these are minimalist definitions of these methods. In other words, at line 2, we return null. We have to return something to get by the compiler. And at lines 3 and 4, we have empty bodies. The critical thing is that none of these functions throws an exception. And this basically tells the Java runtime, the security engine, that everything is okay. So you'll see if you unpack the zip file, there is no TrustStore file included. We basically don't need one because of lines 1 through 4, and then the follow-up setup below that. Now, let me do a demo to show you how this all works. As noted, there's a README in the zip file that repeats this, but it's always good to see that the code actually runs. So let's do that now. So I'm going to my bash shell. I have Java temp convert client. That's the compiled version, obviously. It expects 2 command line arguments, the username and the password, and these are the same as in the earlier examples. So the client makes 3 calls against the service, and as you can see, the output here is illustrating what the inputs and outputs were. So the inputs to the service were 3 temperatures. The outputs were the conversions of those 3 temperatures. In summary, what we've looked at is the slightly higher level API that you get on the client side if you're going against a SOAP-based as opposed to a REST-style service. In effect, we could stay with the REST-style approach if we wanted to, even in a SOAP-based service. But if you're going to write a SOAP-based client, you might as well take advantage of the higher level API.